Welcome to the Deep Dive, where we extract the most important nuggets of knowledge from a stack of sources, just for you. Today, we're diving into something really fundamental, yet maybe often overlooked. The actual science of how people learn. I mean, when was the last time you truly stopped and thought about the intricate processes happening when you pick up a new skill or grasp a new idea?
It's a great question because learning, well, it isn't just for school, right? It's this constant lifelong thing, often happening without us even fully realizing it. So, our mission today is really to demystify that process a bit, help you understand yourself as a learner, no matter your age or where you are.
And for this deep dive, we're leaning heavily on a really comprehensive report. It's from the National Academies of Sciences, Engineering, and Medicine called How People Learn Two Audis, Learners, Contexts, and Cultures. And this isn't about like memorizing dates or definitions. It's more about unpacking that complex dance between your biology, your environment, and, yeah, your personal choices and how you learn.
Exactly. We'll explore some maybe surprising things about how your brain adapts the different types of learning you're doing all the time.
And crucially, offer some practical strategies too to help you become, an even more effective learner throughout your life.
That's the plan. Think of it as a kind of shortcut to being really well informed about, well, yourself.
Okay, sounds good.
Yeah.
So let's jump right in. Who are you, really, as a learner?
Well, after formal schooling, like K through 12, what you learn and how much you learn, it becomes increasingly driven by your own choices, your circumstances.
So less about following a curriculum and more about life,
Yeah.
career training, hobbies.
Yeah, exactly. Everything from job skills to picking up a new language, even just figuring out daily stuff. You really become the active architect of your own learning journey.
And that journey, it brings some pretty interesting changes related to age, doesn't it? In terms of our cognitive resources.
It does. As we get older, two key abilities actually start to diverge a bit. Our reasoning skills, that ability to quickly generate, transform, manipulate new information, they can begin to decline maybe after early adulthood.
Okay, that sounds a bit concerning.
We'll wait for the other side of it
Mm.
because here's the really profound insight. Our accumulated knowledge, our expertise, that's largely retained. Sometimes it even increases.
So experience counts.
A lot. A huge amount. And what's truly remarkable is how that existing knowledge actually helps compensate for potential declines in that raw reasoning capacity. It's not just coping, it sort of reframes how we think about wisdom.
So in the real world, someone with decades of experience might actually outperform someone younger with faster processing speed because they just know more.
Exactly. Their deep knowledge base allows them to see patterns, make connections, and solve problems more efficiently, even if the pure speed isn't quite what it was. It really highlights the value of that lived experience.
Can you give us an example? Like, how does that compensation actually work?
Sure. There were studies, for instance, showing that older adults who already knew a lot about general health topics, they could learn new information about, say, heart disease much more easily, especially when they could go at their own pace.
Because they had a framework already.
Precisely. That existing foundation just made it easier to slot the new information in. It wasn't just about learning faster, but learning more efficiently, maybe more deeply, because of what they already knew.
That makes sense. And it sounds like our reasons for learning also change as we age. It's not just what we learn, but why we learn it.
Absolutely. That drive for maybe external achievement or recognition, climbing the ladder, getting the promotion that might lessen a bit for some people.
And what replaces it?
Often it's an increased desire to use the skills you already have
Yeah.
to help others, maybe mentor younger colleagues, or just to maintain that feeling of competence and engagement with the world.
So learning needs to feel more personally relevant.
Very much so. For older learners, training and learning opportunities are usually most effective when they boost that sense of self-efficacy, belief in your own abilities, when they build directly on existing knowledge, and when they have immediate practical relevance to their lives. It has to feel meaningful, not just abstract.
But we should be careful not to paint everyone with the same brush, right? These are averages. There must be huge individual differences.
Oh, absolutely critical point. Huge variability. You have some individuals, researchers call them superagers, who cognitively perform like people decades younger. Their brains might even look younger on scans.
Wow. So what shapes that unique path?
It's this complex mix: your environment, your overall health, definitely sleep habits, even exposure to things like pollutants, and of course, all your personal experiences, schooling, work, family life, hobbies. It's like a unique blueprint for how each person ages and learns.
Okay, so our biology, our age, our choices, They're all part of the picture.
Hmm.
But learning isn't just happening inside our heads in isolation, is it? You mentioned context, culture.
Right. If we zoom out, learning is profoundly influenced by the specific context and culture you're embedded in. Culture isn't just like background noise, it's a dynamic, living system.
How so? How does it shape learning directly?
Well, it shapes not only what people learn and the skills and knowledge valued in that society, but also how they learn. We can define culture as basically the learned behavior of a group passed down across generations. It's expressed in actions, beliefs, tools, social norms. It's everywhere.
And this starts really early, with how caregivers interact with children.
Incredibly early. Those first experiences, shaped by cultural norms around child rearing, they influence how children learn, what they learn, how quickly they learn certain things, and even what the kind of developmental endpoint looks like.
Is there an example of that? Different cultural approaches?
Yeah, there's a fascinating study comparing parents in the US and Vanuatu. US parents often saw a child deviating from a model, maybe in drawing or building, as showing creativity. But Vanuatu parents tended to equate precise imitation with intelligence.
So, completely different values placed on imitation versus variation.
Exactly. And those values directly shape how children are encouraged to learn and what kinds of learning behaviors get reinforced. It shows how our environment literally sculpts our earliest learning habits.
And it goes beyond just social learning, right? Culture can even shape our basic perception. I'm thinking of that optical illusion, the Muller-Lyer illusion.
Yes. The one with the lines and arrows where lines of the same length look different. Classic study. It found that people living in urban, industrialized environments full of straight lines, right angles, corners, were much more susceptible to the illusion.
Compared to people in environments without those features.
Right, compared to those living in, say, more natural environments without as many carpentered corners. It's a powerful demonstration that our physical environment, shaped by our culture, can literally train our brains to perceive the world in certain ways. Our perceptions aren't just given, they're constructed by experience.
Which really makes you wonder, how much of our learning is fundamentally social? Is it mostly me and my brain, or is it me and others?
It's profoundly social. I mean, think about the work of Vygotsky, a key figure in this area. He really emphasized that cognitive growth happens through social interactions. Kids, adults too, solving problems together, using the tools their culture provides, language, writing, calculators, you name it, tools passed down through generations.
Our brains are kind of wired for that connection.
Absolutely. And that connection is a huge engine for learning. Our everyday cultural practices, the routines, the ways we interact, they structure how we think, how we remember, how we approach problems.
Can you give another example of that? Everyday practices shaping thinking.
Sure. Consider the Oksapmin people in Papua New Guinea. They have this unique system for counting using parts of the body, which fundamentally shapes their mathematical thinking in ways different from, say, a base 10 system. Or, among some Mayan communities, learning often happens through incredibly keen observation within daily family life, rather than explicit instruction.
So these aren't just like quaint customs. They're actual learning systems embedded in the culture.
Precisely. They are fundamental ways that knowledge and skills are transmitted and developed.
Okay, this really paints a picture of learning as this dynamic interplay, doesn't it? Coordinating multiple systems inside you, but also interacting constantly with these dynamic, changing contexts.
Exactly. There's a model by Bronfenbrenner, Ecological Systems Theory, that visualizes this really well. Imagine concentric rings.
Okay.
The innermost ring is your immediate environment, family, school, work. Then broader rings encompass wider social settings, community structures, all the way out to overarching cultural beliefs, ideologies, customs.
And they all influence each other
Yeah.
and influence the learner in the middle.
Constantly interacting, shaping development and learning in complex ways. And what's really profound here is how deeply these social and emotional contexts affect your brain function.
How so?
Well, here's a kind of neurobiological truth. It's pretty much impossible to think deeply about or remember information that you have no emotional connection to.
Really? Why is that?
Because the healthy brain is efficient. It doesn't waste energy processing or storing information that doesn't seem to matter to you, that doesn't evoke some kind of feeling, whether it's curiosity, interest, fear, whatever. Emotion acts like a relevance tag for memory.
That's powerful. So if you're not emotionally engaged, learning gets much harder.
Definitely. And the flip side is even more stark. What happens when those fundamental social and emotional needs aren't met at all?
Uh-oh.
Well, there are some tragic examples. Studies of children raised in Romanian institutions in the past. Even though their basic physical needs for food and shelter were met, the lack of stable, loving social relationships, that consistent emotional connection,
What was the effect?
it led to documented stunted physical growth and critically impaired brain development. It's a devastating illustration of how essential social and emotional well-being is for our basic biology and our capacity to learn.
Wow. So it's not just about feelings, it's about actual brain structure and function.
Absolutely. But it's not only the social emotional side. Our physical state matters hugely too. Think about something as basic as nutrition.
Right. Fuel for the brain.
Exactly. Adequate protein, calories, essential nutrients, they're absolutely crucial for brain development and ongoing function. Something like iron deficiency in infancy, for example, can unfortunately lead to lasting cognitive impairments. The brain needs the right building blocks and fuel to work properly.
And what about sleep? We all know we need it. But how badly does skimping on it affect learning?
Oh, dramatically. Sleep loss seriously impairs pretty much all key cognitive functions: attention, vigilance, working memory, decision-making.
Okay, but how much loss are we talking? Like pulling one all-nighter?
Get this. Research showed that just 36 hours of continuous sleep deprivation, basically, one all-nighter plus the following day, resulted in a 40% loss in the ability to form new memories.
40%. That's staggering.
It really is. You're literally crippling your brain's ability to learn efficiently when you sacrifice sleep like that. It puts those late-night cramming sessions into a very different perspective, doesn't it?
It certainly does. Okay, so nutrition, sleep. What about exercise?
Also, hugely beneficial. Regular physical activity is great for learning and cognition. It seems to improve concentration, help with complex tasks like reading comprehension, and boost what we call executive functions planning, organizing, inhibiting impulses.
Does the type of exercise matter?
There's some evidence that more challenging, coordinated exercise things that require you to think and move precisely, maybe like dance or complex sports, might have even stronger cognitive benefits. It pushes both the body and the brain.
And one more physical factor we probably shouldn't ignore: environmental toxins.
No, definitely not. Especially during critical periods of development, exposure to neurotoxins like lead, even at very low levels previously thought safe, can have really serious, irreversible consequences for cognitive function, affecting IQ, reading ability, writing skills.
So the air we breathe, the water we drink, the environment we live in, it's all part of our learning context.
It's all interconnected. Our physical well-being and our environment form the foundation upon which learning happens.
Okay, so we've covered the learner, the context. Let's dive into the brain's role more directly. How does this all actually play out when we learn specific things? Maybe walk us through a few different learning scenarios.
Good idea. Let's take Kayla. She's learning the Pythagorean theorem in her geometry class. What's happening there?
Okay, she's learning terms like hypotenuse, rules like a squared plus b squared equals c squared, maybe visualizing triangles.
Exactly. She's creating spatial models, linking algebraic concepts to geometry, applying the theorem to solve problems. She might even start to see the underlying idea relationships in networks and transfer it to totally different contexts, like communication systems. It's multi-layered.
Okay, scenario 2, Martina learning guitar. That seems different.
It is. There's significant motor learning, getting her fingers to press the right frets cleanly. There's perceptual learning, hearing a chord in a song and being able to pick it out, distinguish major from minor. And probably observational learning, too, watching how other guitarists play.
And for her, practice is key, right? Repetition.
Absolutely. Practice, maybe a strict regimen, even finding ways to reward herself for progress. Those are all crucial for that kind of skill acquisition.
All right, one more. You mentioned this protein folding game, Fold It. That sounded fascinating.
Oh, it's incredible. Fold It is this online game where players, regular people, not necessarily scientists, learn to fold digital models of proteins into their most stable, efficient shapes. It's a hugely complex, real-world problem in biology.
And they actually solve things.
Get this. In 2011, Fold It players solved the structure of a key enzyme related to an AIDS-causing virus. It was a problem that had stumped professional researchers for 15 years.
Wow. How did they do it? Just trial and error.
It was much more sophisticated. They developed new tools within the game, like software recipes for folding strategies. They collaborated in teams, shared their solutions online, critiqued each other's attempts, updated everyone on what worked and what failed. It was this massive, distributed, collective learning effort.
That's amazing. It really broadens the definition of learning.
It does. And these scenarios highlight that the basic types of learning we engage in rarely operate in isolation. They're all interacting.
So what are some of those basic types?
Well, there's habit formation and conditioning. Think of Martina practicing guitar daily that becomes an ingrained behavior, maybe strengthened by the reward of sounding better. It can be conscious or unconscious. Pavlov's dogs are the classic example, right? Even our immune systems can be conditioned.
Then there's the observational learning we touched on with Markina, learning just by watching others.
Exactly. Humans are exceptionally good at this, sometimes called no-trial learning, because you can pick things up without trying and failing yourself. Think about kids on a playground. They often figure out how to behave by watching their peers, the descriptive norms, what people actually do, rather than just following the official rules, the injunctive norms.
Interesting. What else?
There's implicit pattern learning, also called statistical learning. This is your brain detecting regularities in the environment without you even consciously trying.
Like how babies learn language.
Precisely.
Mhm.
Even tiny infants, like 8-month-olds, can pick up on the statistical patterns in speech sounds, figuring out where words likely begin and end, long before they know grammar rules explicitly. It's fundamental to language acquisition.
Okay, and you mentioned perceptual and motor learning with the guitar example.
Right. Acquiring skills through sensory experience or physical practice, often without being able to fully articulate how you do it. Distinguishing musical chords, perfecting a tennis serve, or even a dermatologist getting that feel for distinguishing different skin conditions through sheer experience.
Is there a really striking example of perceptual learning?
Oh, yeah. The McCullough effect is kind of mind-bending. If you stare briefly at, say, vertical green stripes and horizontal red stripes, afterwards, if you look at plain black and white vertical stripes, they might look pinkish and horizontal ones greenish.
For how long?
Here's the kicker. That effect can last for months for some people.
Months from brief exposure.
Yeah. It's a dramatic illustration of how experience can fundamentally and persistently change our perception. Once you've learned to see something a certain way based on your past input, it's really hard to unsee it. It shows how deeply experience wires our sensory systems.
Okay, that's wild. What about more straightforward learning, like facts?
Humans excel at learning facts, especially through language. Someone can just tell you that mushroom is poisonous, and you learn to avoid it without needing a direct negative experience.
Thankfully.
Right. But facts are rarely learned well in just one go. They stick better when we connect them to knowledge we already have, when we organize them logically, and especially when we practice retrieving them repeatedly.
And finally, there's learning by making inferences, right? Figuring things out.
Yes, critical thinking. Often called abductive reasoning, forming the best possible explanation for what you observe. Like a detective piecing together clues.
Like discovering Neptune. That was based on weirdness in Uranus's orbit, wasn't it?
Exactly. They inferred the existence and location of an unseen planet based on its gravitational effects. A crucial type of inference is building mental models. We use models like the Earth being round, or how a thermostat works to understand things and make predictions.
But sometimes our models are wrong.
Very often. Misconceptions frequently come from faulty implicit models, like kids thinking the Earth is a flat pancake, or people thinking turning a thermostat way up heats a room faster, the incorrect valve model instead of an on-off switch. The fold-it players. They were essentially creating new, better models algorithms to solve the protein folding puzzle.
It's just incredible to think about the organ doing all this. The brain, it's not static, is it?
Not at all. Brain development is lifelong. It doesn't stop in childhood. It continues well into adulthood and beyond. Connections, synapses are constantly being formed, strengthened, and pruned based on our experiences. It's a dynamic, living network.
And this adaptability, this plasticity is key.
Absolutely key. The brain's ability to change and reorganize itself is remarkable. One fascinating concept is neural recycling.
Recycling, like reusing parts?
Kind of, yeah. The brain repurposes existing areas, often those evolved for one function, to handle new cognitive tasks. For instance, studies show that individuals who are blind can recruit parts of their visual cortex to process spatial information coming from hearing or touch.
Wow. So the brain area isn't just tied to one sense.
It suggests the organization might be more about the type of computation, the logic of thought, rather than strictly the sensory input channel. It's incredibly flexible.
And individual neurons get tuned, like the violinist example.
Right. Over your lifetime, neurons become tuned to respond best to patterns and stimuli you encounter frequently. Violinists show greater sensory cortex representation for the fingers on their left hand, the one doing the complex fretting because of years of practice. It shows that reciprocal relationship, learning literally shapes the brain's structure and function, and that changed brain then enables further learning.
Can intense learning actually change the brain physically?
Yes. Studies have shown, for example, that periods of intense study, like medical students preparing for major exams, can lead to measurable increases in gray matter in relevant brain areas.
That's amazing. And this adaptability continues into older age.
It does. Bilingualism, for instance, seems to boost cognitive resilience later in life, possibly because constantly managing two language systems exercises the brain's executive functions. And even when some cognitive abilities might decline with age, older adults often compensate effectively by recruiting different or additional neural networks, sometimes using both hemispheres of the brain for a task where younger adults might only use one. It's a form of neural adaptation, part of what we might informally call wisdom, finding new ways to achieve goals using the resources available.
Okay, this is all fascinating context on how learning works.
Yeah.
But let's make it really practical. Based on all this science, what are some of the most effective strategies you can use to actually learn better and retain information?
Great question. Let's start with strategies focused on getting knowledge to stick. One of the most powerful is retrieval practice.
Retrieval,
Yep.
like testing yourself.
Exactly. The simple act of actively recalling information from memory strengthens that memory much, much more than just passively rereading it. Even if you try to recall something and fail, that effort is beneficial.
Oh, so
Because it clearly signals to you what you don't know yet, highlighting where you need to focus your attention next. So, the big takeaway for listeners: actively test yourself. Don't just reread your notes, close the book, and try to explain the concept out loud or write it down from memory.
Okay, retrieval practice. What else?
Spaced practice. This is about timing. Distributing your learning sessions over time is far more effective for long-term retention than cramming everything into one marathon session.
So, studying a little bit each day is better than pulling an all-nighter before the test, which we already learned is bad for memory anyway.
Precisely. Reviewing material, say, a day after you first learn it, then maybe a week later, then a month later, that spacing helps consolidate the memory for the long haul. A study with fifth graders learning vocabulary found that spacing practice sessions about 2 weeks apart led to the best long-term retention.
Makes sense? Fighting that forgetting curve. Any other retention strategies?
Yes, interleaved and varied practice. This means mixing up different types of problems or skills within a single study session, rather than practicing one thing over and over before moving to the next. That's called blocking.
So instead of doing 20 math problems of type A, then 20 of type B, you should mix them up. A, B, A, B.
Exactly. It feels harder in the moment, which is why researchers call it creating desirable difficulties. But that extra effort forces your brain to constantly retrieve different strategies and discriminate between problem types, leading to deeper, more flexible learning and better long-term performance.
Okay, so retrieval, spacing, interleaving for retention. What about strategies for deeper understanding and integrating new knowledge, not just memorizing?
Good distinction. Here, things like summarizing and drawing can be very effective.
Yeah.
Summarizing forces you to identify the core ideas and put them in your own words.
And drawing, like mind maps or diagrams.
Yeah, using graphic representations, flowcharts, diagrams, concept maps to show relationships between ideas. It can be especially powerful for understanding complex systems or spatial relationships. It engages a different part of your processing.
You mentioned handwriting earlier.
Yeah.
Does that tie in here?
It does seem to. That study by Mueller and Oppenheimer found students taking notes by hand generally had better conceptual understanding than those typing on laptops.
Why was that?
The researchers hypothesized that because handwriting is slower, it forces you to process and summarize the information as you go, rather than just transcribing lectures verbatim, which is easier to do when typing quickly. That active processing leads to deeper understanding.
Interesting. What about asking questions or explaining things?
Absolutely key. Developing explanations is crucial. One technique is elaborative interrogation.
Collaborative, what now?
Elaborative interrogation. It basically means asking yourself deep why questions about the material as you learn it. Why is this true? Why does this happen? How does this connect to what I already know? It pushes you beyond surface level facts into reasoning.
And related to that is self-explanation.
Yes. This involves explaining concepts or the steps you took to solve a problem out loud to yourself. It's a bit more open-ended than elaborative interrogation. You're articulating your understanding, which helps you identify gaps or inconsistencies in your thinking. It works best when you already have some prior knowledge to build on, though,
And probably the ultimate test of understanding.
is teaching it to someone else. Preparing to teach material is an incredibly effective learning strategy.
Why? Because you have to really get it straight in your own head first.
Exactly. It forces you to organize the information logically, integrate different pieces, retrieve it accurately, and figure out how to explain it clearly. Studies even show that students who simply expect they will have to teach the material later learn it better than students who are just studying for a regular test. That anticipation changes how they engage with the material.
So find a willing friend or family member and try to teach them what you're learning.
Or even just pretend. The act of preparation itself is powerful. It really underlines that learning is an active process, not passive reception.
This has been a fascinating journey. We've gone from the aging brain to cultural influences, sleep deprivation, optical illusions, protein folding games. It really underscores how complex learning is.
It truly is a constant interplay of your biology, your culture, your social world, your physical health, and importantly, your own choices and efforts. From the brain's amazing adaptability to the different ways we absorb and process information, learning is definitely not a passive activity.
And the key takeaway seems to be that you are an active participant. You're constantly shaping your own learning path. Your motivation matters, the choices you make about how to learn matter, the environments you put yourself in. They all play a huge role in your lifelong development.
Absolutely. This knowledge really empowers you to be more intentional about your own learning and growth.
So let's leave our listeners with a final thought. Considering everything we've discussed, how cultural practices, social connections, even your physical health, profoundly shape how you learn, how might you intentionally design your daily life? Think about your routines, your interactions, the environments you frequent. How could you tweak them to foster deeper, more resilient learning, not just for yourself, but maybe for those around you too?
Yeah, what's one small intentional shift you could make, maybe even this week, to really embrace learning, not just as something you have to do sometimes, but as a true lifelong adventure?
Something to definitely think about.